Hi students, so now we will be solving this particular problem which says that integration of 2x square plus 1 divided by 9x square plus 5 into dx. Now in the last video I had already told you, I think in the last video I had already told you that I'll be solving one more problem based on long division method in case you did not understand or get the concepts that I shared with you in the last video. Okay, so here since the power of x is 2 in the numerator and also we have the power of x as 2 in the denominator, so here most likely there is no other way by which we can proceed, but we can use long division method here to simplify our problem, as there is no other possible way by which I can break this problem down. All right, so how will I approach with this long division method? Please watch it carefully. Okay, so 9x square plus 5, and I'll divide that, this 2x square plus 1 by 9x square plus 5, right? So now see here, if I multiply 9x square plus 5 by say 2 by 9, okay, what will I get? I'll be getting, if now multiply this, 9x square into 2 by 9 is nothing but 2x square, right? Plus 5 2s are 10, and there will be a 9 in the denominator. Is that clear? So now what we will be doing is, since we have already got it up here, now we will so multiply it by 2 by 9 exactly. So if I do that, then I'll be getting what here? 2x square as usual, and here I'll be getting a 10 by 9. Now as I had already said that our main ambition will be to cancel, we will have to ensure that the x square or x cube, whatever term is present, that has to get cancelled. So here there is a plus sign here and there is also a plus sign here, so we will simply convert it to a negative sign. So 2x square minus 2x square is nothing but 0, and 1 minus 10 by 9 is nothing but a minus 1 by 9. Is that clear? So now we cannot further multiply or do any further breakdowns, all right, because it's not possible as there is no term of x here. All right, so we will have this as our quotient 2 by 9, and we will have minus 1 by 9 as our remainder. So now how will we put it down here? As I told you in the last video, that the quotient will come first like this. Is that clear? And after that we will be putting a minus sign here, since we have a minus 1 by 9. So, and in the denominator we will be having this particular part, that is 9x square plus 5, this into dx. Is that clear? Now this problem, all right, this particular problem is now entirely solved. Why? Because now the next step is just to do the integration, but before that we have to formulate this part a little bit. How will we be doing that? Let's see. So we have integration of 2 by 9 into dx minus, let's take 1 by 9 out of the integration sign, and then we will be left with a 9x square plus 5 in the denominator, right? Dx will be here. So 9x square plus 5 is there in the denominator. Now essentially we have dealt with formulas which says that 1 by x square plus a square integration of 1 by x square plus a square into dx is nothing but 1 by a tan inverse of x by a plus c. So this is something that we have dealt with. But unfortunately here we have 9x square. That is, we have a coefficient of x here. But essentially in the formula, the coefficient of x is nothing but 1. So our first responsibility will be to remove the coefficient of x square. So how can we exactly do that? Simply take 9 common. If I take 9 common, then here I will be getting an x square. And what about a 5? I'll get a 9 in the denominator. Will I or will I not? Because as you do 9x square here, you get 9x square, and then plus 9 into 5 by 9 is nothing but 5. Why did I do this kind of manipulation? Because our major concern here is to bring the particular expression into this particular form. And as we know that in the formula, the coefficient of x square is actually 1. So we have to remove the coefficient, any other coefficient present in front of x, we have to remove it. So in order to remove the coefficient of x, we had to take 9 common, and as we took 9 common, this became an x square. Now the x square part is free of any form of coefficient, and in place of 5 we are now having a 5 by 9. Is that clear? If it is not, if you can't understand why did I put this 5 by 9, you can also take it the other way around, that say if I have an 9x square plus 5, okay, and say I want to take 9 common from both of the terms. So you can imagine that I am multiplying by 9 in the numerator and dividing by 9 in the denominator. So ultimately these two things get cancelled and I get a 5. So in the next step, if I take 9 common, then inside I'll get an x square plus 5 by 9, because 9 has been taken as common. Alright, so I explained you exactly 2 ways. Whichever you feel comfortable with, you can go ahead with. Alright. So this is the thing. Now our concern is to integrate, but first we will manipulate it a bit more. How? I'll take this 1 by 9 outside of the integration sign, and inside of the integration sign I'll be left with an x square plus a square. Now one more concern. What is the concern? Our a is not exactly in the format that it should be. X square is here, but where is a square? In order to express 5 by 9 as 5 by 9 is actually a square here. Alright, so a will be what? Root over of 5 by 9. Is that clear? What is root 5? Root 5 is nothing but root 5. But what is root 9? Root 9 is nothing but 3. Alright, so we can write, so a is our root 5 by 3 here, and the whole square, and this is how we arrive to the basic expression. Now we are fully ready to integrate. I hope you understood this. Alright, you have been given the a square here. A square is 5 by 9. So what will be a? Nothing but root 5 by 3. Is that clear? Now simply we have to integrate, and we know that the integration of 1 dot dx is nothing but x. This will be 1 by 81 only, 1 by 9 into 9. Integration of 1 by x square plus a square is nothing but what? 1 by a. What is our a here? Root 5 by 3 into tan inverse of x by a, right? So tan inverse of x, what we have as x? X is x here, root 5 by 3. Is that clear? Please put a bracket for more clarification, plus c. So ultimately I'll be left with a 2 by 9x minus 1 by, this 3 comes in the numerator, 3 and 81 after cancellation becomes 1 by 27. Root 5 will stay as root 5. Tan inverse of this 3 will come in the numerator, so I'll get a 3x divided by root 5, alright, plus c. So this is our final answer for this particular question. I have explained a lot actually, like every possible step I have explained, all right? Even the long division method, or what is a square, what is considered to be a square, all right? How to bring a particular expression into the format which is into the standardized format that we need in order to apply the formula. All of these things have been explained in this problem, and this problem was important not because of how difficult it was, because this was an easy problem, but here in this formula, what are the key takeaways? The first thing is that you learnt is the long division method, in case you weren't aware of it. And the second thing is how to bring the particular expression that you have, this particular expression that you had, how to bring that expression into the standardized format so that we can directly apply the formula. These are the two key takeaways of the particular problem that we solved. This is the reason why I did give so much of time, like over 10 minutes, to solve this problem. So if you like my video, then please don't forget to like, share, subscribe, and hit the notification bell icon for more of such exciting content. All right. So keep learning, and thank you very much. Let's move on to the next video.